Hi guys, so I wanted to make you a video regarding the area under the curve. It was our introductory lesson to integrals. So at the beginning of the school year, we did a worksheet that had several different little squiggly lines on it. I know you guys didn't know what they were, but now we are going back to and addressing it. We had a squiggly line, which we now know is it means taking the integral. And I gave you something like this, the integral of 2dx. I told you to look from 0 to 3. And what we did was we took whatever this was, set it to like y equals, so y equals whatever that is, in this case y equals 2. You would draw it. Y equals 2 is a horizontal line. And that was easy. But then I told you that, or we learned that the information that's over here, the 0 to 3, those are our intervals that we're interested in. So I only wanted to know about that graph in between x equals 0 and x equals 3. Cut everything else off. And what I'm interested in, of course, is what the area of this shape would be. Well, it is 3 units long, 2 units high, and 3 times 2 is 6. So the answer to this was 6. So another example was 3dx. This time I want it from 1 to 5. So you draw your line here, but we're only interested in the interval between 1 and 5. So only wanted this area right here. We had to be careful because this length or this width was 4 units wide. The height was only 3 units wide, and so the answer was 12. Last but not least, we had an example negative 2dx from like 0 to 4. And we drew our line here, only up to 4. We were interested in this area, that it had a height of negative 2 and a width of 4, and the answer was negative 8. We had some discussion about the existence of negative area. However, this does come into play later on when we start talking about profit and loss, water reservoirs, other things like that. So just bear with me. So in our next example, we have parts of the graph that are above and below the x-axis. So we have the integral from negative 2 to positive 1 of 2x dx. And what we do is, again, we're going to graph this function, which is 2x, and I'm only interested between negative 2 and 1. What makes it really easy is I can just plug in those values in between there, so it helped me with my graph. If I plugged in negative 2, I would have something at negative 2, negative 4, negative 1, negative 2, 0, and 1, 2. I'm going to try to connect these to the best of my abilities. Boom. And what we do is, to create our shapes, you draw a vertical line from one end directly down or up to the x-axis. So if I'm below the x-axis, I'm going to be drawing up to the x-axis. If I'm above the x-axis, I'm going to be drawing below the x-axis. Of course, you should be able to see that these makes two distinct shapes, and they are triangles. And the area of a triangle is 1/2 base times height. The main difference between these two triangles is going to be that this one's going to have a negative area and this one's going to have a positive area. So starting with the triangle on the left, I know that its area is going to be negative. I already know the area is going to be negative. Other than that, I know that to find the area, we're going to do 1/2 its base, which is 2 times height, which is 4. And of course, negative 1/2 times 2 times 4 is going to be negative 4. And the area of this triangle is negative 4. So now I want to find the area of the triangle on the right. And I know for a fact that it's going to be positive. It's going to be positive 1/2 its base, which is 1 times height, which is 2. And of course, that means it's the area of that section is 1. So what we do is we combine these two to get our final answer. So the area is going to be equal to 1, which I got from here, minus 4. And I got the minus 4 from there. So our final answer would be negative 3. All right, so next we're going to talk about the areas of common geometric figures, starting with our very first example. I have the integral from 1 to 3 of 4 dx. So, of course, I would start drawing my graph, but I'm only interested in between x equals 1 and x equals 3. I want to know what's the area of this shape. First of all, let's recognize the shape. What is this shape? Hopefully we can all tell that it's a rectangle. And how do you find the area of a rectangle? Well, hopefully we know that area is length times width. All right, so find the area of this shape. Well, I know that it's 2 units long. It is 4 units high or wide, and 2 times 4 equals 8. So that's the answer. Next, I'm giving you the integral from 0 to 3 of x plus 2 dx. So, of course, you would be graphing x plus 2. It's going to be a linear graph. I'm interested in the space between 0 and 3. So if I were to plug in a 0, I'll have a point at 2, 3, 4, and 5. And since I'm interested in the interval between 0 and 3, I again draw a line straight down to the x-axis. And just because I want to, I'm going to color in my shapes. So, what is this shape? This shape is a trapezoid. And you may have this memorized, you may not, but the formula to find the area, I'm just going to draw because I need the space. The formula to find the area of a trapezoid is 1/2, let me put area equals 1/2 base 1 plus base 2 times the height. So when I'm referring to base 1 and base 2, this is base 1, this is base 2, and the space from here to here is your height. So in this case, when we're looking for the area of this trapezoid, it will be 1/2 base 1, which is 2, plus base 2, which is 5, times the height, which in this case is 3. So if you multiply all that together, you should get that your answer is 21/2 or 10.5. Last but not least, we have this integral from -2 to +2, the square root of 4 minus x squared dx. This is another common one. Actually, I'm going to need a different graph. There we are, much better. All right, so you may recognize this, you may not. Just in case you don't, I mean, you can always plug in your points. You would get a point here. At 0, you would get one here. And at +2, you would get one here. And it would make this shape right here. Well, what is this shape called? This is a semicircle, or half a circle, and it has a radius of 2. I forgot to color my shape in. There we go. That makes me more happy. So what's the formula to find the area? Well, if this is half of a circle, what is the area of a circle? The area of a circle is pi r squared. So the area of a semicircle is going to be 1/2 pi r squared. And then what is the specific area of this particular shape? It's going to be 1/2 times pi times 2 squared, which is 4. So our answer is going to be 2 pi. And that concludes the first lesson of area under the curve.